Good morning, everyone. Good afternoon, good evening, wherever you are in the world. We're grateful to have you join us on another Sawtooth webinar. This one's entitled Segment Finder, Finding Needs-Based Segments in CBC and MaxDiff Data. And we're privileged to be joined today by the two Brians, Brian Orm from Sawtooth and Brian McEwen from Sawtooth Software. We'll announce them a little bit later in a few moments, introduce them. Okay, so yeah, a few details here. We do have a Q&A section here in Zoom at the bottom. We ask you to use that to ask questions. You can ask your questions during the webinar, but we will also have a Q&A section at the end. So either of those times, we don't use the chat feature in Zoom. A recording of the webinar will be sent out to everyone who registered, and we'll also send out the slides. Just a few upcoming events we'd like to announce. Coming up next month, we will have another Sawtooth webinar, and it's entitled The Massive ROI of Conjoint Research. And on January 15th, we'll have another webinar entitled When Data Disagrees, Earning Stakeholder Trust. So I encourage you to check out those webinars coming up. And also a plug for our Sawtooth Research Conference. This next year, May 6th through 8th, will be out in Berlin, Germany. And registration for that conference is coming soon. And you can see more details on everything here at sawtooth.com/events. Just a little plug for Sawtooth. If you don't know about us, we create powerful survey software. We're really good at conjoint and MaxDiff, easy to use, and also just a solid survey interviewing platform. You can try us for free at discover.sawtoothsoftware or discover.sawtooth.com. Okay, many of you probably already know Brian, but I'll introduce him. Brian is the CEO and president of Sawtooth Software. He's been doing research for over 33 years. He's the author of 2 books on conjoint analysis and has written 100 plus white papers on conjoint and MaxDiff. I would say he's probably the world expert on conjoint. Uh, he loves travel and scuba diving. So that's Brian with a Y, Brian Orm. And then we also have Brian with the I, Brian McEwen. Brian is a senior advisor and product manager here at Sawtooth. He was the former managing director out in Sawtooth's UK office, and he joined Sawtooth back in 2008 and has a lot of experience doing customer support and teaching people about conjoint and MaxDiff and how to use our products. I'm grateful to work with both of these guys. They're great coworkers. And with that, Brian Orm, if you'd like to turn on your camera, and we'll turn the time over to you.
Great. Thank you for the introduction. Let me cue up my slides. When we talk about market segmentation, you typically have to just have to start with the joke that you would hear from your professor in Stats 101 back at the university, the one about the statistician who drowned crossing a river with an average depth of 1/2 meter of water. Ba-dum-tsh. The point being for us as researchers is that looking only at averages can mask a lot of important critical things happening at the segment or individual level. In terms of cases or in market research, we are typically dealing with cases being each respondent. So let's give an example not about crossing a river, but involving brand preference. Let's imagine that we conduct a survey asking respondents to rate brand X from 0 to 10. And if the average score across 500 respondents is 5 for brand X, what could this mean? Does it mean that people feel middle of the road in terms of brand X? Well, alternate explanations are that half of the respondents think very highly of brand X, they give it a 10, and half think very poorly of brand X. They give it a 0. Or it varies significantly between age groups. Young people are giving brand X an 8 on average, and older people are giving it a 2 on average. Or maybe it varies significantly due to household income. Or finally, maybe respondents were just answering randomly and we're getting a 5 as the average of those random numbers just due to low motivation. So there's lots of different explanations that could be going on if we see across 500 respondents that we're getting a 5 rating for on average for brand X. So, the point is that you're usually not trying to market to the average consumer. Segments and individuals differ in terms of their preferences for brands and features, performance, style, price, etc. Sometimes those segments of respondents can be identified by age, by income, or other variables that you can ask about or observe about them. But sometimes the segments that you want to target can't be identified by observable segmentation questions. Rather, that these segments that could be important for your targeting could be latent. Latent meaning that they're not observable with a simple segmentation question. You can't just include a question to obtain this segmentation, but this segmentation can be found using another method that we're going to be talking about. So why do this market segmentation? Well, we want to find out about and target the segments that would be most receptive to your product or service if we're talking about the typical marketing research case. Or maybe we're about to create new products or modifications to our products or services, and we want to create those multiple options that better meet the needs of a diverse set of customers and can increase our market share and hopefully won't be subject to a lot of cannibalization of our own product line. So how do you do this market segmentation? That's a needs-based segmentation focused on developing a product or developing messages that reach segments of people who think differently. Again, you could segment people based on variables you already know about or ask about or can ask about. Maybe these variables are going to be the ones that help you target people and create new products that are specific to them in terms of making them happy. Maybe you're lucky in that these variables like geography and company size, age, income will get you where you need to be in terms of market segmentation. Or, and this is often the case, that those stated variables that you can throw into surveys don't give you quite the segments that you would be as useful for you for these purposes. So then you turn to a latent type of segmentation. You classify people based on latent segmentation variables that are revealed using a series of, for example, importance questions about needs, desires, and price sensitivity. And the historic approach has been to create a series of questions using rating scales, followed by cluster analysis, often k-means. If any of you have done this in the past, you're probably cringing because this often fails miserably if we ask, let's say, 10 or 20 ratings-based questions in a grid or one question at a time about needs, desires, price sensitivity. It often fails miserably just due to lack of discrimination. A lot of respondents just kind of say, well, everything's important. I'll give you a bunch of 5s and 4s or 8s, 9s, and 10s. And you just get not very much discrimination for the algorithm to be able to grab onto and separate much signal from noise. The other big problem with rating scales in this historic approach to segmentation is scaled use bias. Different people, and particularly different groups of people, such as cross-culturally, Germans are known to use a little bit lower scale points on average than South Americans or people from India, for example. These are just norms that follow over, we've seen this many times. And what can happen is if groups of people are answering higher on the scale versus lower on the scale, and that's mainly due to cultural bias. just the way that that they're more yay saying or more no, nay saying, you can get a segmentation where the main thing that's driving the segmentation is whether you're a German or a South American. It's not really whether you prefer more price sensitive or you prefer a particular brand or that you need more performance. That's not really coming out. It's the scale use bias that's often driving the majority of what this segmentation, these k-means segmentations on these batteries of standard survey questions are. So this just doesn't work out well. And MaxDiff or CBC, MaxDiff, also known as best worst scaling or choice-based conjoint, analyzed by latent class multinomial logistic regression, latent class MNL, which is a type of finite mixture modeling, is much, much better. It gets better discrimination and it avoids scale use bias. Because these choice methods, MaxDiff or CBC, force choices. It doesn't really force choices. We'll talk about that in a moment, or trade-offs among attributes and items. These methodologies, whether it's MaxDiff or CBC, engage respondents more, encouraging to use their brains to think carefully rather than just being more lazy and typically straightlining us. Now, they don't force choices because respondents can just quit, for example, but we typically say that these are forced trade-offs. And in that sense, respondents can't just say everything's important. They can't just say, oh, everything's a 5 on a 5-point scale. With CBC and MaxDiff, we don't let them do that. Now, of course, alternatively, respondents can just get lazy and answer randomly if they don't want to engage with us. But we will find that by looking at hierarchical Bayes' fit statistic. And so that we can clean the data afterward if some respondents won't engage with us. But these methods do so much better at engaging people to actually discriminate and think about the importance of these attributes and features involving product choice. And they avoid scale use bias. There's no scale. We're not asking people to rate products or messages on a 5 or a 10-point scale. There's no scale to use. We're asking people to choose the best or choose the best and the worst. Okay? So we're going to be able to avoid the issue, for example, and I'm generalizing, that Germans potentially use generally lower points on a rating scale than South Americans. It doesn't matter with MaxDiff and CBC whether you have scale use bias because we're not asking a scale. We're just asking you to choose best or best and worst. That means that you're going to get much more meaningful discrimination among the items and attribute levels from MaxDiff and CBC than you'll get from some, say, rating scales. Your t-tests between items, your f-tests across groups of people are going to be much stronger with the same sample size when you use MaxDiff and CBC with choice data to conduct market segmentation than if you use the schlocky approach of rating scales, which often fails miserably. So what you get from latent class MNL, whether you're running it on MaxDiff or CBC, is you get, in the first case, the number of groups or classes that you as the analyst request. Just like cluster analysis, you as a researcher need to say to the algorithm, hey, go out and look for the 2-group, the 3-group, the 4-group solution, and let me look at some of those solutions and figure out which one works best for me. And measures of model fit help you decide which is more appropriate, and I'll talk about that in a minute. The other thing that you get from latent class MNL is the size of each group, the size of each class, okay? And you're probably going to ignore groups that are too small. If you have a segment that pops out that has 2% of respondents, you're probably going to want to rethink things, do some data cleaning, not take that solution because it's just typically not very useful to think about targeting or think about considering a group that only has 2% of the sample or 4% or whatever your threshold might be. The last thing that you get from latent class MNL is segment assignment for each respondent. Each respondent actually has a probability of assignment to the groups. So if there's 2 groups, I might be 83% in group 1 and 17% in group 2. But typically, to make things easier to deal with and to explain to clients, we typically will classify people into the group that they have the highest probability of membership into. Let me talk a little bit about how the algorithm works. This is an intuitive explanation rather than the full math. So forgive me on that. If you're a real math person, you can look it up in the Latent Class technical paper to get the more full specifications. But this is essentially how it works. The analyst specifies how many segments to look for. Let's say K segments. And let's imagine that K is 3. So for the 3 segments, we're going to randomly select smallish initial preference weights for the attributes that are assumed to drive choice. So if it's a conjoint model, we're going to have the part worth utilities for segment 1, for segment 2, for segment 3. And we're going to have 3 vectors of part worth utilities, and we're going to randomly flip a coin and make tiny little preference weight differences right around 0, like, plus 0.01, minus 0.01, plus, just a tiny bit of signal to get the algorithm going. You can't start with all zeros or else the algorithm can't get going. So after you've initially seeded the algorithm with some random starts, you calculate the likelihood in step 1 that each respondent belongs to each of those K segments, each of those 3 segments, given the respondent's answers. We compare it to the utilities and say, hey, which one of these segments best fits this respondent? And we can calculate likelihoods that sum to 100. So for each of the K segments, each of the 3 segments, we're going to run 3 weighted regressions where the weights are the respondent's likelihoods of belonging to each segment. So each respondent is involved every time, but each respondent gets a different weight when we're updating the utilities for the segment 1, when we're updating utilities for segment 2. Each respondent is used, but has a different weight in each of the 3 weighted regressions. And we repeat. And obviously, when you run those weighted regressions, you're going to get a new set of utilities, which are different from our initial plus 0.1, minus 0.1 starting points. And then we repeat steps 1 and 2 until the fit of the model fails to improve by very much. And then we break out and we say, hey, we think we're good enough. But that final solution that we break out at depends, unfortunately, on the initial random start. A challenge with these methods is that you might stumble into an unlucky suboptimal solution if you're unlucky with your initial set of random weights. So the simple thing to do, obviously, is to do it multiple times from different random starting points and to take as the final solution the one that leads to the best model fit in terms of log likelihood or BIC. Either one will tell you the same answer. In terms of pointing to which of these 5 or 10 these 10 tries that you're doing from different starting points is the best one that fits the data the best. So you run it multiple times, take the one that fits the data the best, and that way you avoid getting an unlucky solution due to an unlucky starting point. So one of the big questions with latent class or cluster analysis or any of these methodologies that find latent segments is how to pick the best one for your client or the best one for the data or the best one for the social research study that you're doing. From a statistical standpoint, the Bayesian information criterion, BIC, can be used to identify the solution, the 2-group, 3-group, 4-group solution, et cetera, that has the best justifiable fit to the data. Here is the formula for it. It involves the log likelihood, and it involves a penalty for the number of parameters we're estimating, which also involves the number of parameters in the model, the number of part worth utilities, for example, that you're fitting, and the number of segments you're fitting them for. So similar to the idea of adjusted R-squared that you might have been taught many years ago, we want to see as we add more segments that we're getting not only better fit to the data, but we're not just getting spurious fit due to just adding more parameters to the model, that these additional segments actually provide justifiable fit to the data, okay? We adjust, the BIC adjusts the model by the number of parameters to say, hey, yeah, we added more parameters. Did we get really enough fit to justify that we're going after yet another segment? Interestingly enough, unlike things like R squared or adjusted R squared, lower BIC numbers are better. So we want to see lower numbers, and that indicates a more justifiable fit to a segmentate, to more inherent segmentation goodness in the data that it's captured by the parameters. But you shouldn't just look at the BIC and say to your client, hey, the 6 segmentation solution has the lowest BIC, the best fit. So that's the one, dear client, that you should take. You really should think to yourself, what does the client need? Because choosing the latent class solution that has the lowest BIC may not necessarily be the thing that helps your client the most. You should rather prioritize the latent class segmentation solution that's the most useful for answering the business or research question. The most useful one typically isn't the 2-group solution. And the most useful one, at least from a strategic segmentation in terms of a segmentation that's helpful, understandable, memorable, is probably not the 15-group solution either, okay? In our experience, it's typically the 3 to 6 group solutions that are the ones that, from a strategic standpoint, are most helpful, understandable, and memorable for communicating throughout the organization, for creating messages or target products that reach those segments, et cetera, et cetera. After thinking about that, you should look at solutions in terms of BIC, but make that, if you're trying to break the tie between the 4-group and the 5-group solution, both of them seem to work well for your client. You probably want to look at the one that has the best by BIC and let that break your tie. Getting close to the end before I turn it over to Brian McEwen, who's going to show you how it works within the new segment finder in Discover. That's coming in a minute, and he's going to do a great job. Latent class, MNL, or hierarchical. I say that because maybe I'm boring you at this point. You're like, just show me the software. I'm getting close. Latent class or hierarchical based. Some people ask that. Well, there are 2 methods that I can use to estimate utilities. Well, latent class MNL produces both those utilities and, importantly, segmentation assignment, whereas hierarchical based does a really good job of finding individual level utilities. You could use the segment utility weights from latent class to build a market simulator and make predictions of choices. But we think that you should use the 2 for what we believe that they're best at. Use latent class for classifying respondents and finding those segments, and then use the classification variable. Maybe it's a 3-group variable that has each respondent's assigned to a 1, 2, or 3. Use that as a segmentation variable, and then, or crosstabs, and segment your predictions that come from using individual level data at the respondent level. So each respondent is voting for their products according to their HB utilities, but you are slicing and dicing and segmenting by the classification variable that came out of latent class. Last slide for me, some practical suggestions for latent class segmentation. Don't field sparse CBC or MaxDiff studies and hope to get great segmentations. Rather, make sure that you don't skimp on the number of questions that the standard kind of rules of thumb would suggest. The standard rules of thumb are to show each item in MaxDiff at least 3 times to each respondent. And for CBC, a standard rule of thumb is to make sure that each attribute level appears at least 6 times for each respondent. If you field sparse questionnaires that go much below this, this will lead to really low ability to find meaningful segments. Second practical suggestion is before running latent class, clean the data, because if you include random responders, and we often are finding from 20 to 50% of respondents who are just not doing a very engaged job, unfortunately, today, these random responders will often form their own group of meaningless responses. There often will be their own latent class. And your client might look at that and say, oh my gosh, I like the pattern of preferences in that group. And you guys start talking about and thinking about how to target those respondents. And in the end, they were just random responders. I've heard of this actually happening where they had to back up and say, oops, that group that we fell in love with was actually the group of random responders. They don't really exist. Okay. I mean, they exist as random respondents, but the signal that we're seeing just is not going to be reproducible if we repeat the study. It's fiction. So clean the data before running latent class. Hierarchical Bayes provides an excellent way to clean the data from MaxDiff, also from CBC. It can do a creditable job. Identify those respondents with fit statistics that are near the chance level. We have other white papers that talk about that if you want to ask us about how to clean the data according to HB's fit statistic, the RLH. The next thing is use multiple criteria to identify bad respondents. Low HB fit statistic is one that I just mentioned, but speeders, okay? Some speeders are actually really good respondents. They just read fast and answer quickly. So just because it appears that they're speeding doesn't mean that they're bad, but it could be one strike in a multiple strike setup that you have for identifying bad respondents. Look at straight lining from grids, if you have any grids in there, or other repeated questions where you could identify straight liners. Look at your standard consistency checks. Maybe you ask people what date they were born in early in the questionnaire, and later in the questionnaire, you ask them their age, and then you compare their date of birth to their stated age and see how consistent they are. And there are other consistency checks that you can do. There are also, hidden honey pots that only bots can see, et cetera, et cetera. Looking at the quality of open ends, for example, can help you also try to figure out whether a respondent is being very conscientious or not. So there's other data that are implemented in a number of panel platforms for trying to figure out whether the data that we're seeing seem to come from a survey farm or from a bot. Okay, so there's lots of checks, and maybe you have 6 or 7 strikes that a respondent can get. And maybe after a respondent gets 2 or 3 strikes, you say, hey, that's enough evidence that we think that they are bad. And just clean them out before running latent class. There, I've set the table for you, Brian McEwen, and please take over. And I'm boring them enough. Show them the software. Show them how great of a job we've done with Discover with Segment Finder.
Okay. Let me go ahead and start sharing my screen here. And we're gonna do something a little risky. We're gonna try to segment live. It might blow up in our face, but we'll see how it goes. I've got a different survey that has a guaranteed solution that has come out well, but we're gonna see how it goes. I've got a very simple survey that we've got programmed up. It's got just 2 questions at the beginning about your current phone and how old it is, a little intro about screen size, and then a conjoint exercise trading off the brand of a phone, how big the screen size is, whether or not it has an AI assistant, the amount of storage, and then the levels of price. So I've got this survey published. We're gonna take a minute and share it with everyone. Justin's gonna put this link in the chat as well, but if you want to scan the screen with a QR code, you can take it on your phone, or if you want to type in sawtooth.com/phones, that's going to take you to the survey.
I did put it in the chat, so you should just be able to click on it in the chat if you can find the chat.
Awesome. Thanks. So we're gonna pause just for a minute. I'm gonna come back in 60 seconds, talk a little bit more about this, and give everyone an opportunity to generate some data and see how it goes. Okay, I'm gonna put on my product manager hat very briefly, and just number one, tell you how easy we've made it to program these type of exercises. Discover is our online platform. If you are our desktop user, Lighthouse Studio, Sawtooth has had tools for running this type of segmentation work for a lot of years. This is something we just recently added into Discover, where we can do, skip logic and quotas and all that sort of stuff, and then add in our expertise in conjoint and MaxDiff. If you haven't tried out Discover, give it a shot. I've actually got a preview mode here going on where I've got access to nested attributes or alternative specific designs. And I've also got the option to merge attributes visually. And I've got a second survey up where we've got some nice enhancements coming to CBC exercises where we're going to be running some design tests, give you some recommended sample sizes, kind of make sure that you're in a good spot or alert you to any warnings coming down the pipeline. All these features should be coming out within the next few weeks, and we're very, very excited about them. Let me check the data really quick, and hopefully we've got quite a lot of completes. That's great. Let's go ahead. So what I'm going to do is I'm going to start the analysis here. It's going to take a minute or two to run both, because we have to run both our hierarchical Bayes individual level utility models, and then we're also then going to run the segment finder to look for these existing groups of people. So I'm going to come in here and start this off. And that's going to kind of run up in the cloud. So as we wait for that, I'm going to switch over to a MaxDiff just so you can also see the results over there. This was an anchored MaxDiff. It was a message testing for a new cola concept for a new cola soft drink. So we had a lot of different messages here about it was mountain themed and it was 0 calories. So a lot of different options here. And as you can see in the MaxDiff, everyone would see a couple at a time and choose the one that they liked the most and least here. And so segment finder is an addition to our typical analysis. So this was an anchored MaxDiff. We have our anchor point, and then we estimate scores for all of our items. So nothing changes there. That's kind of an independent analysis. With segment finder, we ran a couple different segmentation solutions. You can see I've got them as tabs up here, my 2, 3, and 4 segment solutions. Under our details, this is where you see that fit statistic, the Bayesian information criterion. Remember what Brian said. This is kind of an inverted graph. So lower numbers are better. So we decided to visualize it and flip it here so that lower numbers go up. And you can see kind of that example here where statistically, according to this fit statistic here, we're not seeing a lot of improvement as we increase segments. And this also kind of passes the sniff test here. So if I go to my 2-segment solution, this actually has an interesting segmentation come out of it. Segment 1, so up here we have the greatest differentiators. So this is taking all of the scores. We generate scores for both of the groups. And these are generating, looking at where the biggest differences are for me and just highlighting a couple of those top ones. And that's really helpful. It makes it really clear that segment 1 really likes the messages about the no calorie aspect of the soda, whereas segment 2 is appreciating the kind of adventurous, a taste adventure in every bottle, and taste the thrill, share the chill. They kind of like. So that's interesting. You can see that kind of reflected as well. A lot of these other adventurous ones where bold meets refreshing, unleash the flavor. They've got the higher scores coming out of here. Um, Satisfy those cravings, boldness in every bubble, the coal that's adventurous as you are. Those are all generally doing better, consistently above the anchor, and being chosen as best more by this segment two. Whereas segment one, a lot of people, they're right close to that anchor threshold of this is a good message or not. But those 0 calorie options, only made with natural ingredients, and then satisfying those craving also does a little well with this group as well. So pretty interesting segmentation solution. And then, of course, these methods are very friendly. If we ask it, like Brian said, to just keep going and keep going, it will find segments. It will do its best job at it. So there is this element of evaluating and not just looking on the fit statistic and kind of taking it at face value. So if we kind of think about what happened now with our 3 segment solution, you can see segment 3 now is still that low calorie favoring group that's going on here. Segment 1 and segment 2, however, their greatest differentiators, some of these aren't that big of a difference, right? You do have a difference about embrace the bold flavor of mountains in every sip. A taste adventure in every bottle is also pretty much being the same. So this is kind of that art part of the science, right? Where it's maybe not quite as interesting and explainable of why all these segments exist, which is the opposite of the 2 segment solution, where it's very clear what was going on. So that is, I think, also reflected in the fit statistic. We're kind of splitting the 2 group solution as we further create these groups. So we're not statistically really improving. And as we look here, we're seeing kind of the same thing. Segment 3 is that low calorie solution. And then segment 1 just kind of is stronger in preference for a lot of the adventurous mountainous options. So there are some differences, but again, it's kind of hard to tell an interesting story as we move on to the 2 and 4 group. As we move on to the 3 and 4 group solutions. So this is the interesting part of segmentation. It's not just clear cut. You're always going to get an answer. They're not necessarily going to be the most useful answers. But this was a very interesting group here. Because we ran our HB utilities, we can still do the turf analysis, the total unduplicated reach and frequency. Interestingly, if we do that and say, for example, what 2 messages are the top for as many people as possible who took my survey, then that's the 0 calories, 100% flavor, and the satisfy those cravings. Remember, satisfy those cravings kind of tested well in the adventurous group as well. So again, passing the sniff test, we're seeing similar things in an ideal bundle of messages. And then what's also cool, these are just variables in my survey now. And so I ran some crosstabs. And again, a very interesting outcome. If we take that 2-segment solution and we look at the gender question that we had in the survey, there's an equal number of people in both groups. This does not line up with a lot of these demographics. If we look at our age question, we've got a little bit going on where segment 2 kind of has a little more in the 26 to 35 and 36 to 55 group. The people who are a bit more adventurous tended to drink Coca-Cola more, whereas the low-calorie segment 1 tended to like Coke Zero and Diet Coke a little bit more. So that kind of tracks a little bit, but that's an interesting thing. We can look to see, do these needs-based segments correlate with any of our other survey questions? Sometimes they will, sometimes they won't. It's just something you have to investigate. This question asked how often people drink soda, and again, not very big differences in this one. These low calorie and or adventurous people seem to not line up. So going back to what Brian was saying, if we're just looking at averages, we can miss these insights that are latent, that are hidden in our data set. So that's pretty interesting there. Okay, let's head back here. And we'll go to our analysis area. And so overall, we've got some, this is kind of what I was hoping for. We've got some strong preferences. Apple, the Chinese brand, not doing quite as well. People tending to prefer larger screens. So interesting, nothing crazy going on here. It looks like we had a couple extra people take the survey finish. So I think we'll just leave it as is. Some of you aren't represented here. That is okay. So let's take a look. So this is live. We'll see what's going on. We've got our two segment solution. Interestingly enough, I was hoping for this. We've got segment one are people who really prefer Apple and also have a much higher tendency to say none of these, which tracks in the survey. Sometimes you didn't see an Apple phone on the screen, whereas the Android people had a lot more options, and so their non-utility is lower than the Apple people.
Brian, I just have to say that's me, right? I chose Apple every time, but if Apple wasn't there or if it was too expensive, I would say none. I would never do something that wasn't Apple. That was me personally.
Yep. Yeah. And that's what I was going for. I was hoping for a strong segmentation solution here. So that's pretty great. If we look at all the utilities, doesn't look like we have a ton else going on. Android users tended to choose the lower prices a bit more, which again makes sense given the competitive landscape. Let's look to see if there's anything in the three segment solution here. So we've still got our Apple people here. We've split it out. These numbers have gotten a little bit stronger, so we must have taken some of those Apple people out. And it looks like now we've got a very, very strongly price-driven segment in segment one, who still doesn't feel as negatively about Apple, but is primarily driven by that low price point. Let's see if there's anything else popping out here. Looks like we've got a little bit of preference. That group one also tended to prefer not having an AI assistant on the phone. So that's kind of an interesting thing going on there. So yeah, experiment successful. Thanks everyone for that data. And hopefully you can see the benefit of putting people into groups and especially with these methods that help you hunt for these groups of people that do not necessarily correlate with traditional demographics. We might, in this example, we might have been able to come up with some questions that might correlate really highly, right? But it's really nice that if you're already running a conjoint or a MaxDiff for some other purpose, you can very easily run this type of segmentation analysis, and then wait to see if anything interesting comes out.
Brian, could we see the BIC statistic on our data here?
Oh yeah, let's do that. So I didn't run a huge number of groups. I didn't want it to take super long while we're in the background, but we do get a bump as we go from no segments up to 2, and then a small increase as we go up to 3 segments.
Yeah, and I just mentioned that one segment solution. A one segment latent class solution is aggregate logit MNL.
Yep. So that represents the set of utilities that is as if we're analyzing this as if we just smushed all the answers together and we treated it like one person who answered all of the choice tasks. That's what those utilities represent. For people who might be a little more technical, you can actually produce utilities from latent class just by itself. Brian mentioned that you have the opportunity to see the um, likelihood of group membership. So if I was, 100% group one, then we could create a set of utilities for me that look exactly like group one. If I was like 60-40 group one and group two, we can create a set of utilities. However, like Brian mentioned before, we generally think HB is the better set of utilities to use. So if I was going to come into the simulator and I was going to start running some choice predictions of I've got an Apple phone here versus a Samsung phone. This is going to use the HB utilities. There's no settings to choose or anything. So when we're looking at the averages, that's going to be using the HB utilities. If we wanted to segment by the type of phone that people have, yep, so everything's passing the sniff test. People who have iPhones really like iPhones. Um, and people who have iPhones are less price sensitive. That's all tracking. So this is all going to be using the HB utilities, and that's actually the same thing here for our segment finder reports. We are creating the group assignment for people, but all of this is using the HB utilities to produce the charts and graphs and simulations and the turf analysis and MaxDiff and
Hey,
all
Brian,
that.
can you address where do I see how respondents are assigned to segment one or segment two? How do I see that? Respondent by respondent. How do I know what they're assigned to?
If you want to get those respondent by respondent segments, then you can download everything comes out into an Excel spreadsheet. If we came into the records area and click download data, this would give us one row per respondent, and then all our columns would be the raw choices, the survey answers, and then we would export out the segmentation data, the utilities, all that good stuff would come out in an Excel file or an SPSS file if you wanted to take that and run it somewhere else. Okay, and with that, I will turn it back over to Justin.
Okay. Thanks, guys. Let's see here. Just a reminder here of our upcoming events. Right? We will be having this November 20th webinar, The Massive ROI of Conjoint Research, January 15th, When Data Disagrees. And then remember our May conference, May 2026, out in Germany. Always the best event Sawtooth puts on is our Sawtooth Research Conference. Really encourage you to get out to that. Brian, if we have time, maybe you can talk a little bit more about that. Just a reminder, hey, you can check this out for free at discover.sawtoothsoftware.com. Brian, I'd like you to make a comment on Lighthouse Studio. I know there's some questions about that. Can you address that first, and then let's get into the Q&A?
Yeah, Lighthouse Studio for many years has had its version of Segment Finder. It's just called Latent Class over there. So when you collect MaxDiff or CBC data and you go into the analysis manager and you say run utilities, well, one of the methods to run utilities is called Latent Class, and you'll get what you get here. I will bring up a little technical point. There is something called scale constraints, so that we try to avoid solutions where the main difference between segments is just in terms of the response error. And so in Discover, we're running scale constrained latent class, which is the same available in Lighthouse Studio, but you have to go find that option and say, constrain my scale to be the same across groups to avoid these weird solutions where I get different groups, but it's just due to response error and the magnitude of the utilities.
Okay, thank you. Brian McEwen, if you want to turn on your camera and participate as well. And we think Keith Sean has been in the background helping out. Keith leads our consulting group and is an expert on segmentation. So, Brian, I don't know if you want to lead us and kind of read through.
Sure. And I might bring, I know there's one of these questions that I'd like to bring Keith in. So Keith, be prepared to turn your camera on because I think I have one for you. One is there a way to create a typing tool for MaxDiff or CBC segmentation solutions that doesn't require asking the entire MaxDiff or CBC questionnaire? And the answer to that has been addressed a couple of times in the last 15 years at Sawtooth conferences is yes. You can do it. You can find the magic 3 or 4 or 5 MaxDiff questions or the magic 3 or 4 or 5 CBC questions so that you don't have to ask all 9 or all 13 questions, and it will do a high likelihood of assignment. Keith's practice often creates segmentation tools, typing tools for MaxDiff and CBC. There's various methods to do it. If you write me, I will be glad to show you some white papers talking about the methods that you can use to do it, the statistical methods. And so I just say it's available, it's possible, it's an advanced methodology, and it's something that Keith's consulting group often does for clients. Next, SIG tests. A couple of questions came up about SIG tests. We're working on it in Discover. We don't have SIG tests in there yet for the cross tabulations, but we'll get to it. I slide down a little bit. There was a good one that I wanted Keith to address. Yes, Keith, can you answer this one? What levers can we pull if we find that the segmentation solutions that are coming out of Latent Class or CBC Segment Finder aren't what we're looking for? They're not actionable. They don't make intuitive sense for the client. The client says, hey, this one really isn't resonating with me. What other levers can we pull?
In that case, I would probably do a similar thing to what I would do if I were doing a segmentation on survey data. If I tried, if I wasn't finding the segmentation I wanted on variables X1 through X20, maybe I look at a different set of variables. Maybe I add some new variables in. Maybe I try a different algorithm. If I were working with survey data, maybe I'd try latent class instead of k-means, or maybe I would try cluster ensembles. I might try a different take of this, on the same variables with a different analysis method. And likewise, if Sawtooth Software's latent class analysis wasn't finding the segments I wanted, and I wanted to stick with the same variables, I might hop into a program in R and do my latent class clustering there, or my latent class multinomial logit there, or I might use latent gold software.
Okay, let's also take a look at some other questions here. So let's slide. I'm sorry, I'm bringing up my own Q&A so that I can control sliding and looking. Okay. Oh, is it possible to do latent class analysis or segment finder with adaptive CBC, with Sawtooth's ACBC, which is in Lighthouse Studio? Yes, it does. Yes, it's possible. We did not build latent class directly into ACBC. So if you've collected an ACBC in Lighthouse Studio and you go to analysis, you're not going to see latent class as one of the methodologies. And you might say, well, why not, Brian? This was something that I decided on. The second main section that provides so much data for adaptive CBC is the screening section, where we show near neighbor products to the BYO one at a time. And we say, is it a possibility or not? Is it a possibility or not? Well, the or not answer is the none parameter, is the none alternative in ACBC. And we found that people's propensity, we felt that people's propensity just to say not, or yes, it is a possibility would be therefore highly driving the segmentation solution, leading to segmentation solutions that were mainly the propensity of respondents in that section to be more yay-saying or nay-saying regarding whether these products were a possibility for them. So we were cautious about that. And in the documentation, we recommend that you run HB, export the utilities, normalize them so that each person has the same magnitude of utilities, and then try another methodology such as k-means or something on that. We generally recommend latent class for almost every choice methodology, but for ACBC, it's a little bit questionable. You can export the data from ACBC to that old CHO format and run latent class, the standalone latent class on it. If you want to throw caution to the wind in terms of my caution about people's using that middle section, the screening section, and run latent class on it. But you could do a number of other methodologies, including hierarchical Bayes followed by k-means. I say that holding my nose a little bit because we generally don't recommend running k-means on hierarchical Bayes utilities, but ACBC is a special case. And I think it requires a little bit more thought because of that screener section. Oh, can latent class and discover be used for rating scales? No, not yet. You can run latent class. It's just called latent class clustering. It's not latent class MNL because you don't have a dependent variable. You don't have a choice variable that you're fitting the MNL equation to, but you can run latent class just like you can run k-means on a series of rating scales, and latent class probably does a little bit better. Holding rating scale constant and rating scale data, I already said, were kind of messy and yucky, but it's not available yet. We hope to add latent class clustering. It's something you can currently do in R or in latent gold, and Keith Shun can point you to some R packages for it. But it's something that we're hoping to add soon to Lighthouse Studio, and maybe in a few years as well to discover, because latent class clustering on standard basis variables like coming out of rating scales is a good methodology. Does anybody else, like Keith, see any other interesting questions that we might answer? We still have a couple minutes before the top of the hour.
I think we're close. Any last parting words from anyone?
Nope.
Just a
Super
reminder to everybody that we will send out a link to this recording along with the slides, and it will also be available on our website. So with that, thanks everybody. Great job. And we will see you for the next webinar. See ya.